In this video, I'm going to show you how you can train a pixel classifier to segment different regions in your image. So here the idea is to segment epithelium and stroma in H&E images. So I still have this image that is open. Something I didn't show you before, you can use this small icon to look at your entire image. So that can be convenient. Just one thing, when this is on, and you can see here it's surrounded in blue, you cannot do anything. So here I'm trying to zoom in, zoom out, moving. Nothing is working just because this is on. And when this is on, it means that so you see the entire image, and there's nothing you can do to change that. So it's not always surrounded in blue, but we see that it's a little bit shaded in gray. If I unclick it, now I can zoom in. So we're going to see how we can train the pixel classifier. But before that, we actually have several images. We have H&E images of prostate. When we do some classification, when we use shadow machine learning methods, it's interesting to have a subset of representative images. And to do that, we're actually going to define one annotation in each image to create a new image that will be a combination of all these annotations. So we'll have something that is more representative of all our images. So that's one. You don't have to do it. You can train a classifier on one image and then go to the next image and open it again, load it, and then keep going by actually loading the annotation you had before. That's one way to do it. But creating a new image which is representative of what you have across your images is actually not a bad idea. So we're going to start with that. We're going to define an annotation, and we'll see that to create an image with the annotation we defined before, we need to actually add a label to the annotation that we're going to call class. Okay, so we're going to use the label region star, which is the regular one used by default by QuPath. It could be anything else, as long as it's the same class across your image. So I'm going to create a rectangle annotation. And in this image, maybe what is interesting is this gland and this kind of thing. So I'm going to create something, quite large, not too large. So if I unselect it, this is just an annotation, rectangle. You can see here. It doesn't have any class associated. So I told you I want to define this annotation as a region star. So then QuPath will know that all the annotations that are region star can be combined together to define a new image. So I'm going to click on region star, and if I select annotation, if I do set class, now as you can see, we can see here region star for this annotation. If I unselect, it has the color blue, navy blue, of the region star class. This is so now this is the right class, and so I'm going to define an annotation in each image. So I can go to another image. So either I do Control S to save or File Save, and then I can go to the next image. Here I'm going to define a new annotation. So the other way, if you want to create an annotation that's going to have the class that is selected, you can click on Auto Set. And now, if I create a new annotation, let's see, something here, like this, it's already in the right class. You see region star. If I unselect it, it's in navy blue. If I change the image without saving, then QuPath asks me if I want to save. So I want to save, yes. So I'm going to create a new image. Now it's already in auto set, so that's already what I want. Here, go to the next, save, yes. Create a new one. So I'm trying to have something, that I didn't see before. I'm not sure I had this kind of stroma before, and so that's why I defined this one. I can go to the next image. Here I have a lot of background, so I'm going to include some background and some of these regions as well. All right, last image. Maybe this kind of structure. This will be interesting. All right. So now I can create my image. I need to save it because if I don't save it, this annotation won't be associated to this image. So now all the other images have an annotation and that they've been saved. So they're right, but this one I haven't saved it. So I need to save it before. I'm going to do file save. And now I can create an image. So I'm gonna press Ctrl L. And I'm going to create a training image. So I know it's called something like this. So I can type, beginning of training, and that's what I want. Create training image. So QuPath is asking me which class is used for the annotation I want to group together as a new image. That's region star, preferred image width. I'm going to keep it as is. I'm going to just do OK. And so it's asking me which type of image it is. So I'm combining H&E images. So it's going to be H&E image. Okay. And as you can see now, I have this new image with 6 different parts that corresponds to they correspond to the 6 annotation I made in the images before. I can zoom in and I can go through. So I'm going to use this combination of different images. So, the hope here is that I have something that is more representative of everything I have in my images. And I'm going to train a pixel classifier. So when you train a pixel classifier, you need to define regions for each of the classes you're interested in. So here we want to segment epithelium and stroma. And of course, we're going to need another class, which, most of the time we need to define is the background, because these regions clearly are not epithelium and stroma. It can be also interesting to think from the beginning about other regions that might be of interest. So here we're going to stick to that, but clearly, when you have this, for example, this is not epithelium. This is not stroma. So we'll define it as background. We'll see if if the classifier can deal with background that can be either this or this. We'll see. But it could be interesting to have a different class, for so this is secretion. We also have some necrosis sometimes, so we could have necrosis, we could have, other classes. Here we're going to keep it simple. So I'm going to go in my annotation tab, and I'm going to create the 3 classes I want to define. So here, when you do a right click in this area, you can add class. So in add remove, you have add class. I'm going to create a new one, and I'm going to call it epithelium. All right. Then I'm going to create a new class that I'm going to call stroma. Okay. And finally, a new class that I'm going to call background. So when you type enter, sometimes it just interferes with the class that was selected before. That's why you asked me if I wanted to change the color. But it's all good. I created my 3 classes. I can change the color. So let's have something maybe a little bit more separated from what we have. So like epithelium, I can define it in magenta. Stroma, I can define it in orange, maybe orange. Background in black. Let's say maybe black. And now I can define a few annotations corresponding to this. So let's I'm going to use the brush, for example, and I can navigate with the spacebar. So this is background. I'm going to put this thing that are not, I don't want this to be defined as either epithelium or stroma. I had same thing here and here. Okay, so I define in a few annotations. Background, I'm going to define a few annotation first for epithelium. Let's say this is here. I'm going to have to go much smaller like this. And let's define a few annotations for stroma. Brush like this, this. So as AutoSet is defined, you know, whenever I added the class that is selected, which is added. All right. And now I'm going to start. So I'm going to open the pixel classifier to train it. So if I do Control L, with train I already had it. It's train pixel classifier, right? So first parameter is the kind of classifier I want to use. I actually want to use random trees because in my experience it seems to converge faster for this kind of regions. But artificial neural network would be very appropriate too. The other two are a little bit, maybe you're gonna, for logistic regression and especially for k-nearest neighbor, you expect to have probably a performance that is not as high as what you're going to have with random trees or a single layer of neurons. But I would say I'm going to use the random trees. Second parameter is which resolution you want to use. Okay, so this is related to the different resolution. You know? So if you go to 1, it's really full resolution, and this is pretty low, 64 times less in both X and Y. So the lowest resolution you're going to use, you know, the fastest going to be, even though it's pretty fast. If you go full resolution, it's going to be a little bit slower. The most important here to think about is what you really want to look at, especially here, you know, the tissue level. When you look at your image, what kind of resolution do you look at? For example, if you zoom in a lot, is it really useful to know your tissue? Probably you can know that that's probably easier when you're at the level of resolution, which is like this. I'm just gonna change that. As you can see, there's some background. So that will be fine. I'm just gonna make sure I don't include background. So yeah, which kind of resolution is good? When you look at tissue, you know, full resolution is probably not going to be really useful. So we're going to use something like high. And then the features is really something important. And there's a great tool here that allows you to look at different features. So I'm going to click on Edit. And so by default, you have RGB now selected. We did the hematoxylin and leucine separation with a stain deconvolution. It's going to be, you know, probably it's going to be more informative. So I'm going to use that. Even though here, I don't think it would change much, but the, you know, the useful information is in those two. So we can select them. Then the scales. You can also add other scales. We'll look at it later on. The features, so far only the Gaussian is selected. You can add others, and as I told you, you can look at them. So let's select the first one, and what you can do is then show the features. That's what I want to do. And as you can see here, so we have 6 features, and it's pretty straightforward. Here is the Gaussian for hematoxylin, and the Gaussian is actually it's like blurring a little bit your image. So that's going to be informative about the the main components, what we call in images the low frequencies. So this is for hematoxylin, and then this is the Laplacian of Gaussian. So this is the second order derivative of your image. It's good to add some structural information. Third one is weighted deviation. In that case, I'm not sure it's going to be helpful. You see that it might be helpful for your contours, but in these regions, it might be more, I don't know. But it could be useful, and you know, it's something you can explore. Then this is when you look at the eosin, so that's the Gaussian for the eosin. So again, the low frequencies, structures that are in the eosin, and the weighted deviation. So what I would suggest, if you're not super comfortable with the features, you can always select Gaussian, which is going to be very important, especially for tissues. And Laplacian of Gaussian, it might be good for more structural information, or to be good in your contours and other things like that. So you can just select the first 2 ones. I think it would be okay. But you can always explore the other ones, and there's some useful tips on the QuPath website as well. So I'm going to just select those 2. And then I can start to see what I have. So classification, that's what I want. I want to have the classes. I want to do it everywhere. I can do the live prediction. And the live prediction is great because then you can add or remove, if you want, new annotation. And this new annotation, they're going to feed the classifier, and the classifier is going to update directly. So for visualization, you can click on this and click, but just add the classes or remove them. You can also play with the transparency like this. So you can look both at the image and the classes. I know that for me, for example, it's a bit hard to look at both, so most of the time I rather do that. But it really it's just up to you. So for example, this is tissue. It should be probably epithelium. So I can add some epithelium here, like this. I didn't want. I wanted to use the brush, but it's here. Okay. And when you do that, then it updates automatically. So let's just add like here this region. I'm going to use the brush. If I do this. Wanted to do with brush. Well, it's okay. I'm going to use this, and then you see it updates directly. Something which is really useful is this. It's the amount of data that you annotated. So you see I have very few epithelium annotated compared to stroma and even more background, and that's not great. Ideally, you have a very balanced annotation, so you would have same amount of data. It doesn't have to be strictly the same. It can be a little bit different, but clearly here I need to add more the epithelium for sure. You have, I guess, if you have proportions. So you see, stroma is not that bad. 36, it would be 33, so it's about to be okay. But clearly, there's a big imbalance between those 2 classes. So now I'm gonna add a new annotation to improve, and I'll be back when it's done. All right, so I define annotation across my different images. So you see, maybe not that one because we have annotation everywhere, but in this image, just a few and only stroma. I did it quickly here. The idea is just to show how it works. And the results I got are not perfect, far from it. But at the same time, there's no real perfection, so it's really hard to get perfect results. Anyway, the idea here is that I define annotation. When I look at the pixel classifier, I can see that I have quite balanced annotations. So if we look at the number of annotations, I have more epithelium annotations than background, more than 3 times. But what matters is really the amount of data. And so here, when we look at the whole number of pixels that have been annotated through this annotation, we have something which is quite balanced, which is good. The goal is to try to find all the variability you could come across your images, so all the different situations, and situation where it's just at the limit where it's hard to tell between classes are important as well to help the classifier. So if I look at what I get now with live prediction, so which is really cool with QuPath, but you can do it in live, so you can add and see how it changes the classification and so on. So it's not perfect, it's not that bad. Something we see here, for example, is that we have some isolated regions. That's probably, all of this is probably stroma. But I have quite some annotated, isolated regions like this. And so one way to improve that is to have different resolutions. So if I go back to my features here, I can use edit. So I'm only using the one which corresponds to the one I define here. So the high, it's not the highest resolution. The one here corresponds to the resolution which is defined here, which is 4, which is not the highest resolution. If I go back, it's 4. It's pretty high resolution. Okay. If I go back to the scales, I can add other scales. And basically here, I can add a higher scale. And this will have the effect to regularize my regions, because if you think about it, you have a lower resolution, you're going to have less details in the image, and so more uniform regions. And here, that's what we want to have. It's to have more uniform regions. So generally in applied mathematics, we call it to regularize the data, the results. But that's really to get more uniform regions. For example, if I add 4.0, so a resolution which is 8 times less, if I add this, let's look at this region, for example. Hopefully I'm going to have less spurious pixels in place, and something more regularized, and that's exactly what it does. You see? We have more uniform regions in here and in here, and so maybe we do some mistake, maybe we are less precise, but overall it's probably going to be better. So for example, here when I look at this, this is definitely not epithelium, so I'm going to add. So then you can, when you change that, you can go back and see what makes sense, what doesn't. You can add annotation. It's going to be a little bit slower now because I have this 2 resolution. And you see it looks better. And if you think that it's still not regular enough, you can go back and add another 1 or change the 4 for the 8, for example. And that should be even more regular. Let's see. Yes. That, you see, so it's always a thing, you improve in some places. This is clearly not epithelium. This is just background. I'm going to add it as background and see it improves. So it improved here. All right. So I would have, to keep going back and forth to improve a little bit. I'm gonna say, okay, I'm fine with this. So now what I want to do is save my classifier and then apply it to all my images. So the way to do it is here. You have classifier, and you see you can save it, but for now it's shaded in gray because I can't do it. I need first to define a name. I'm going to define as epithelium stroma HNE. Now it's saved. So it's saved in my project. So I can go to the next image. Save. Yes, I'm going to save the changes. So I keep this annotation. If I want, if I realize that it's not good enough, then I can go back here and add new annotations and try to improve my classifier. If I go back here, now I can apply the pixel classifier. So if I do Control L, so it's not training it anymore. I can type pixel, and the thing now is going to be load pixel classifier. I save the pixel classifier, and then I want to apply it here. Choose model. So here I can, I forgot the A actually when I save it. It's fine. Of stroma. So here it's the one that I saved. I can select it and I can apply it everywhere. And if I want to get annotation for it, I can just create objects. Choose parent objects. Okay. Yes. And then you can do a few things. You can get rid of the very small objects. You can also fill holes, or you can fill holes only above a certain threshold. You can split objects. You can delete the existing objects, etc. So here I'm just going to do it as is. But you can, obviously, so these parameters are pretty straightforward, so it's not hard to understand what's going to happen. And if I do it, all right, if I go to my annotation now, so if I close it, I don't have it anymore, it's still in there. I'm going to delete this annotation, yes, keep descending objects. Okay, no, I guess yes, I just did it in my annotation because it was selected. So I'm going to redo it again. It was my bad. I load the pixel classifier. All right. Create everywhere. Create objects. Full image. Okay. Now it's creating. I'm going to have 3 annotations there. One for the epithelium, one for the stroma, and one for the background. All right. You can fill the annotation by doing Shift F, or in View, you can fill annotation here. So I can better see what I have, the background in black, epithelium in purple, and stroma in orange. So clearly it's not perfect. So if I do, again, Shift F, I can switch between. It's not perfect. It's not completely wrong either. So I would have to spend a little bit more time to improve my classifier probably. I can remove the background. Most of the time it's not going to be very informative, or you can keep it if you want. Of course you have the measures associated in here. So like centroid again, x and y coordinates, the area and the perimeter. The perimeter doesn't make much sense here, but the area might be interesting if you want to compare the stroma area and the epithelium area. You can also have access to them through the table. So if I go on this, if I click on this icon, I can do show annotation measurements. I can have all the measurements associated with the annotation. I have two annotations in that case. And so again, I have the area and the perimeter. So we can save it. You can copy to clipboard, which means you can open Excel or LibreOffice or anything like this, and then just do Control V. It's gonna copy and paste everything you have. The last thing I want to do is to apply it to all my images. I'm going to save it. So here I showed you how you can do it on one image. I could do the same thing for each image. So open, cross-tick 2, then apply it, and so on. You can also do some scripting in QuPath, and when you go on the Workflow tab, it shows you all the different operations we did before, including the last one. So I deleted objects, that was before, but I also created the pixel classifier. Okay? So I can create a script with everything I did, or I can do a right click and copy comment. And so it copied the comment. So now I need to open a script. If I do again, Control R, if I type in script and have new script, for example, I'm going to call it batch epi-stroma HE, for example. It opens an empty script with the name I gave. And now if I paste, so the command appears here. And it's pretty straightforward, as you can see. Create annotation from pixels classifier. Okay. And so that's actually creating the annotation. Pixel classifier is epithelium strom HE, the one I defined before. And these are the parameters that we can add for fill holes and filtering the small areas. So I can now go to one image and run it. It's not going to be very interesting in that case because it's just calling again pixel classifier. So if I do load pixel classifier and do all the steps or do this, it's going to be the same. So it's going to be a little bit faster. It's not going to help a lot. So that would be run here, but I can also do run for project. In that case, I'm going to apply this command for several images. So if I apply on the two things like this, it's going to add all the images. Here I already did for prostate 1, so I want to do it for prostate 2 to 6. So I can select them, hit that. So I have 5 images that are selected. If I do OK, it's going to apply my script to these 5 images. And so now I can just wait for it to be done. So I'm just going to speed up the video so you don't have to wait for the entire processing time here. Alright, it's done. So now I can go to my project and I should have epithelium and stroma for each of these images. If I go to prostate 2, as you can see, we have epithelium, stroma, and background. If I go to prostate 3, same thing. So lots of stroma in here. So the way it's, we see the annotation is just the contours. Sometimes it's a bit misleading because it seems that we don't have stroma here. Again, if I do Shift F, I can see that all these areas in orange are stroma. So I have a lot of stroma actually. Just don't see it. If I zoom in, I think, yeah, it's not always, it's just because it's embedding everything on the side. Sometimes it's not that easy to see it, so it's a good idea to again do Shift F or View Show Fill Annotation here. And so I have this for all the images. Now, if I click here, I can have the information associated with the annotation for this given image. So I have epithelium, background stroma, and the region store. I defined for the for creating the image to do the training. Now, if I want to extract all the information, there's another thing I can do. I do Control L, and I type in export. There's something which is called export measurements. And so it looks the same. You can export all the measurements associated to different kind of annotations for a given number of images. So I'm going to do it for all except the image we actually define. I can do this, for example, then select this one and put it back there. So I'm going to have all these images. The export type I want, the annotation. I want to get, for example, the area of epithelium and stroma for all of them. So it's going to be in the annotations. Then I can define a TSV, a CSV, or comma, CSV semicolon, which might be helpful, especially, for example, so, you know, comma CSV are defined in English, but in France, for example, we use a semicolon, so in that case, it might be useful to use this, or you can use the tab. It works as well. I'm going to give a name, so you can give it here, or directly choose it here, for example. So if I put it on the desktop, measurements, for example, I'm going to save it, export it. All right. Now, if I reduce this, I have this thing, measurements. I can open it with Notepad, or maybe what's going to be easier is to open LibreOffice. Still have an image too running from before. So if I do file open, and if I go on the desktop, measurements, open, it's going to ask me, so it's tab. So if tab is selected here, it's going to see it. You know, if I do it just in comment, it doesn't see it, but I know it's a tab. Okay, and now I have this file with the different images. So prostate 1, 2, 3, 4, 5, 6. So for prostate 1, I deleted the background and the region stars. I don't have it anymore. For the other ones, I only have stroma epithelium. For the other one, I have stroma epithelium, region star, and background. And so I know where they come from. I know the image. I have the class, so I can have stroma, and I have the area. So in pixel square, because I didn't have information, but now I can do some comparison of the ratio between stroma and epithelium, for example, across my images.